Hello dear students, I'm back again with another video lesson. I hope you are all doing well. Today's lesson we are going to talk about the RLC, a series connection to AC circuit. As you can see in this circuit, we have an AC source, which is the magnet and direction of the current changes continuously, and we have an ammeter measuring current and voltmeter measuring potential difference, and we have capacitance, inductance, and resistance, all of them together connecting in series connection to AC circuit. First of all, you have to know in a series connection, like for example, if the resistance and capacitance and inductance are connected in series connection, in series connection according Ohm's law, V is equal to IR. Okay? And in series connection, as we studied in chapter 5, section 3 in galvanometer, in series connection, the total current is equal to current IE total is equal to effective current across resistance and effective current across inductance and effective current across capacitance. Okay, but this is not equal to IM. Be careful. Okay, the same thing that you can write for the maximum value of the current, like IM total is equal to I maximum across resistance, I maximum across inductance, I maximum across capacitance. Okay, the amount of the currents are equal in series connection. Okay, but the potential difference are different. Guys, if you remember in a previous lesson, we studied pure resistance, pure inductance, and capacitance to AC circuit individually, and we studied one by one. If you remember, in pure resistance, both potential difference and current are in phase. The phase difference between them is 0. Okay, and in pure resistance, the resistance does not depend on the frequency, independent of frequency. But in pure inductance, instead of resistance, if you have inductance coil, and instead of resistance, we have impedance. Okay, inductive impedance, which is equal to XL. XL is equal to what? Is equal to 2 pi FL, depending on frequency and coefficient of cell of inductance. In pure cell of inductance to AC circuit, potential difference leads current by pi over 2. The phase difference between them is what? Pi over 2. In pure inductance, potential difference leads current by pi over 2. Or you can say current lags behind potential difference by phase pi over 2. And the last one, if you remember, we studied in capacitor into AC circuit. In capacitor, potential difference lags behind the current. Okay, but so we studied individually. But today's lesson we are solving all of them together. Look, RLC series connection. The phasor diagram RLC series connection to AC circuit. To what? To AC circuit. Guys, for the pure resistance, for what? For pure resistance. In pure resistance, theta is equal to what? Is equal to 0. Between what? Between potential difference and current. Okay? Assume that this is current, I effective across R, V effective across R. Both of the current and potential difference located at the same line. So which means phase difference between them is equal to what? 0. There is no lead, there is no lag between V and I. Both of them are in phase. But in pure inductance, guys, here we have XL. In pure inductance, if you remember, potential difference, look, potential difference, which is VL, leads behind what? Leads what? Leads current. VEL, IEL. Potential difference leads what? Leads current. So can we say current lags behind potential difference? Yes, the same thing. Okay? In pure inductance, potential difference leads current by pi over 2 or by 90 degrees. And for in capacitance, capacitor in AC circuit, in capacitor, potential difference lags behind current. Lag is behind current. What do you mean by lag is behind current? It means located below the 0. Okay? So this becomes what? This one becomes VC, V effective across the capacitance, and the lag is behind what? Behind IC, or current across the capacitance. Okay, I draw all of them together in one figure. This is RLC series connection. RLC series connection, and all of them, they have the angular speed which is rotating, sine omega t. Okay, and guys, the angle between V potential difference across L and VR is 90 degree. Angle between potential difference across capacitance with a potential difference across resistance also 90. But guys, be careful. Angle between VL and VC is equal to 180. Angle between VL, what do you mean by VL? Potential difference across inductance. Okay? VC, potential difference across capacitance. Angle between them is equal to what? Is equal to 180. Okay? Guys, look. Because in series connection, the amount of the current, I total, is equal to IR, IL, IC. All the amount of the currents are equal. In series connection, be careful. But potential difference is not equal. We have to add them. Okay, but how can we add the total potential difference? Because we have right angle here, okay, to determine the total potential difference, guys. What is this? This is VE total. VE total or VM total, okay? It doesn't matter, both the same. Not the same thing, but you can represent both VM or VE, okay? Guys, we have VE total. So here we have what? VC is downward. What is the resultant vector between VL and VC? Guys, we have to add with them as a vector quantity. VL and VC. These two quantities in opposite direction. How can you get the total result, the result between VL and VC? VL and VC, like guys, VLC is equal to what? VLC? VL minus VC. Okay? Can we bring it to here? Yes. It becomes what? VL minus VC. What is this? This is angle. Angle between what? This is angle between total potential difference and potential difference across resistance or total current. Or what? This is also, we can say I total because no difference between them. I equal I total, IR, IC, and IL. Once again, listen carefully, guys. What is this theta? The theta between what? Total potential difference and total current. Or you can say total potential difference and potential difference across resistance. How about this angle? This angle is the angle between what? The total potential difference and potential difference across inductance. How can you determine this angle? This angle is equal to what between VE total and VL? Tan inverse opposite over adjacent. Opposite is what? VL. VL over what? Over adjacent, which is equal to, sorry, is equal to VL over what? VL minus VC, okay? Sorry, VR, here we have VR. Sorry, guys, look. Angle between VE total and VL, this is opposite. VR is opposite. VR over what? VL minus VC. How about this angle? Angle between VE total and I total or VR is equal to what? Tan inverse VL minus VC over VR. By using Pythagorean theorem, you can calculate VE total. VE total is equal to what? Because we have right angle triangle using Pythagorean theorem. Adjacent square, which is VR square, plus what? VL minus VC square. VE total is equal to what? VR square plus VL minus VC square. And angle between VE total and VR is equal to tan inverse VL minus VC. So this is the phasor diagram of the total potential difference in RLC series connection to AC circuit. Guys, at the same time, we can find also the total impedance, which is Z, okay? We have VR here, VL, VC. Guys, VL is equal to what? Is equal to like IXL, okay? Guys, instead we have XL here, and we have XC, and we have resistance. Okay? This is inductive impedance, and this is capacitive impedance, and this is pure resistance. How can we do all of them measured in what? Ohm is the total resistance. How can we determine the total resistance? The total resistance by using what? With Pythagorean theorem, Z. How can we determine Z, the total impedance? Total impedance between what? Pure resistance, inductance, and capacitance. According Pythagorean theorem, XL minus XC located here. What is this? This is XL minus XC. And in adjacent what we have R. Hypotenuse is equal to what? Adjacent square plus opposite square. This is opposite of angle, and this is the adjacent of the angle. Adjacent square plus XL minus XC square. Guys, in this way you can determine the total impedance. For each of them we have resistance. For the pure resistance, if you remember, we had resistance R. In inductive impedance, we had XL, inductive impedance, XL, measured in Ohm. In capacitor, we have inductive capacitance, which is equal to XC. All of them, they resist the current, but in different ways, okay? So the total current, what is the Z total current? Okay, this is total current. Sorry, total resistance. Sorry, guys. Total what? Total resistance. What do you mean by impedance to total impedance, which is, it means that total resistance, okay? Guys, can we determine the angle by the resistance? Yes, why not? Theta is equal to what? Tan inverse opposite over adjacent, XL minus XC over what? R. This is angle between what? Between Z and R. But how about angle between Z and XL? Z and XL is equal to what? Tan inverse R over what? XL minus XC. Okay? This is angle between Z and R, but here is the angle between Z and XL. Guys, according Ohm's law, V is equal to what? VE is equal to I effective R. How about VEL is equal to what? IEL R. V effective across capacitance. I effective across capacitance times what? XC, but here we have XL, sorry guys. XL. VE across resistance, pure resistance, is equal to what? IE across resistance times what? Times resistance. This is Ohm's law. How about for the total, guys? VE total is equal to what? Is equal to IE total times what is the total resistance? Z. So this equation is very important. Pay attention, please. VE total is equal to what? IE total times R? No. IE total times XL? No. IE total times XC? No. VE total is equal to what? IE total times Z, because we have total, okay? And for the total, we have Z, the total resistance. This Z represents for the total resistance, okay? Guys, this equation can be used to determine potential difference across inductance, coil. This one across capacitance. This one across pure resistance. But this one, this is the total potential difference across the source. Okay? And also you can determine VE total, guys. VE total by using Pythagorean theorem, which is equal to VR squared VL minus VC squared. both equations can be used to determine what? VE total. VE total. And also, guys, you can rearrange. IE total is equal to what? VE total over Z. Z is equal to what? VE total over IE total. Impedance or total impedance is the total impedance of the circuit or XL, XC, and measured by ohm. Impedance represents the magnitude of the equivalent resistance of resistance, inductance, and capacitance. And guys, we studied this individually of the pure resistance, inductance, and capacitance. In pure resistance, the phase difference is 0. Both the equation of the current potential difference is like this. Look, in pure resistance, we don't have lead and lag between the potential difference and the current. Both of them are in phase. Phase difference between them is 0. But in pure cell of inductance, potential difference, lead is what? Lead is current. By what? Pi over 2. In capacitor, potential difference across capacitor, lag is behind the current by pi over 2. Negative pi over 2. And guys, just a quick remind. XC is equal to what? 1 over omega C. 1 over 2 pi FC. How about XL? Omega L. 2 pi FL. Guys, if you have in the circuit, if you have resistance and inductance, how can you determine the total impedance? Do we have XC here? No, XC is 0. Do we have VC? No, VC 0. Remove all the XC and FVC here. This circuit we have only inductance and resistance. And the angle becomes what? XL over R or R over XL. In pure resistance, capacitor connecting the series, if a circuit consists of a pure resistance and capacitor, pure resistance and capacitor. Do we have the circuit without resistance in RLC series connection? No, we don't have. The resistance, pure resistance, always must exist in the circuit. The resistance must exist in the circuit, so it doesn't matter if this resistance is the pure resistance or the resistance of the coil. Because sometimes the coil, we have resistance. Sometimes in some question, the coil is not pure. Be careful, guys. If the coil is not pure, it means that the coil has resistance. So we have to count for the resistance of the coil. To find the reading of ammeter, if the question asks us to find reading of ammeter, guys, to find or determine reading of ammeter, so which means you have to find IE total, IE across R, IE across L, across C, okay? In series connection, all they have the same value. All they have the same value. They have the same value in series connection, guys. Okay? In series connection. How about the reading of voltmeter? To find reading of voltmeter, what do you mean by reading of voltmeter? VE total, VER, VE like L, VEC. So what is this? This is the reading of the voltmeter. If the question asks us to find the reading of voltmeter, according to the equation, it depends on the question, which potential difference is required to find it. VE total is equal to what? IE total Z. VER, IER times resistance. VEL, IEL times XL. VEC, IEC times XC. If the phase difference is positive, the circuit has inductance characteristics, so the potential difference leads the current. So when does the potential difference leads the current in the circuit that consists of resistance, inductance, and capacitance? If the potential difference across inductance is less than the potential difference across the capacitance, theta becomes negative. But if VL is bigger than VL bigger than VC. The circuit has inductive characteristics, so the theta will be positive and XL bigger than XC. When this theta is positive, if XL bigger than XC or VL bigger than VC. How about when theta is negative? When does theta negative? If XC bigger than XL, VC bigger than VL. So the angle between VR and VL is 90, but VL VC 180. So be careful, V total has several names like effective value potential difference across the source. What do you mean by this? VE total. Total potential difference, maximum or effective VE total or VM total. The effective value potential difference across each of the coil and resistance, it means that VE total also. So this is the symbols and the names for XL, XC, and so these names and these symbols are very important to recognize the question. Guys, to find potential difference across inductance and capacitance, VLC, guys, VL, VC, how can we determine the VLC potential difference across what? Capacitance and inductance is equal to what? VL minus VC. How about XLC? XL minus XC. Okay? Sample problem 6G. Look at this sample problem. It's very easy. Listen carefully, please. The sample problem says, in a given figure, the figure is given. The circuit is given in this question. Find the reading of shown ammeter and voltmeter. Ammeter and voltmeter. What do you mean by ammeter? IE total, I across R, across L, across C. But guys, be careful because this circuit is connected in series connection. All currents are equal. If you find IE total, it means you find IR, IC, IL, doesn't matter. The same thing. Okay? And the reading of voltmeter, the reading of voltmeter is completely different with the current because potential difference is not equal. Potential difference across the source is not equal to potential difference across resistance, across capacitance, across inductance. Each has its own potential difference. And find phase difference between VR and VT. Phase difference between what? VR and VT. Guys, look at the circuit. We have capacitance, inductance, resistance. Potential difference across pure resistance. Potential difference across inductance. Potential difference across capacitance. And also we have potential difference across capacitance and inductance. VLC. And also we have potential difference across what? All of them. V total. But V total effective is given, guys. VE total. Do we have VE total? Yes. VE total is equal to what? 30 volts. XL also is given 14 ohm. XC 5 ohm. R, the resistance of pure resistor, 12 ohm. Okay? Frequency of the circuit also is given 50 hertz. What is unknown? The first one, the reading of ammeter. Guys, reading of ammeter, you can find IE total, IER, IEC, it doesn't matter. But which one is easiest or which equation can be used? IE total only. IE total is equal to what, guys? Because we have total, we have to use Ohm's law, VE total over what? Z. With IE total, you have to use Z, the total impedance. Do we have VE total? Yes. But we don't have Z. Z is equal to what? The equation of Z, we studied, is equal to R squared plus XL minus XC squared. Do we have R? Yes. Given 12 squared. Do we have XL? 14. Minus XC? 5. Together, square. You have to subtract them. By using your calculator, you can find out Z is equal to what? 15 ohm. You can replace into this equation. VE total was given, guys. 30 divided by 15 is equal to 2 ampere. Because the circuit is connecting in series connection, Can we say IE across R also 2 ampere? Yes. IEC 2 ampere? Yes. IEL 2 ampere? Yes. Why? Because in series connection, current, the value of the current is equal for all like current, capacitance, inductance, and resistance. Okay. Now we found the reading of current. The current is constant, is equal to 2 ampere. Okay. The second unknown, the reading of voltmeter. So we have to find one by one. The first one, VR. Reading of ammeter, VR. How can I determine VR? Ohm's law. VR is equal to what? IR times R. Do we have IR here? Is equal to 2 times, look. How about for VL? Guys, look. VL is equal to what? IL XL. VC, IC, XC. VLC, guys, VLC is also unknown. VL minus VC. Look, bring down this VR. Do we have all currents are the same? 2 ampere. 2 times resistance, 12. Which is equal to 24 volt. What is this? This is potential difference across resistance. Potential difference across inductance. Current equal 2 times. Do we have XL? Yes. 14. 28 volt. What is this? 28 potential difference across inductance. What is this 28 volt? This is potential difference across inductance. Potential difference across capacitance. 2 times 5, 10 volt. This is VC. How about VLC? Because VL and VC are in opposite direction, we have to subtract them. VLC is equal to what? VL we didn't have, but we found. VC 10. 28 minus 10, I got 18 volt. What is this 18 volt? Potential difference across VL and VC. Potential difference across inductance and capacitance. Guys, the last unknown, potential phase difference, between what? VR and V total. Guys, if you remember, what is this? VR. And this one, VE total. This question asks us to find this angle. Angle between what? VE total and VR. Phase difference between what? VR, V total. How about if the question says angle between VT and VL? We have to use another equation. But in this case, this angle is unknown. Theta is equal to what? Pythagorean theorem, guys. What we have in opposite? VL minus VC. Adjacent, VR. Do we have VL minus VC? Yes. VL 28, 10 is equal to 18. Divide by VR, 24. Is 0.25. Tan inverse 0.75, 36.87. Theta is positive or negative. Why? Because XL bigger than X. Or because VL bigger than VC. How about if XC or VC bigger than VL or XL? Theta becomes negative. Guys, this is sample problem 6G. Look at practice 6G question 1. Look at this question. A voltage source of instantaneous value. The instantaneous value is given, which means the equation is given, okay? If the equation is given, guys, be careful. You have to write down the equation. V is equal to 20 sine 100 pi t. Okay? The number before sine is what? Vm. The number before time is what? Omega. Do we have Vm? Yes. Vm is equal to what? 20 volt. Do we have omega? Yes. 100 pi. Rad per second. Guys, how did we get these two values in the equation? Okay, what is this? This is Vm. Vm total. Okay? The maximum. It's connected across a series combination of a pure resistance R, 100 ohm. R is equal to what? 100 ohm. A coil of cell of inductance 0.2 Henry. Cell of inductance, which is a pure resistance, pure inductance, L 0.2 Henry. Calculate total impedance of the circuit and the phase difference between electric current and the total potential difference. What is unknown? Z is unknown and theta is unknown. How can I determine Z and theta? To find Z, you have to use this relation. Z is equal to what, guys? R square plus. Guys, do we have capacitance in this question? No. In this question only we have what? Resistance and inductance. We have only R and XL. We don't have XC. XC is 0. R square plus what? Plus XL, because we don't have XC. Don't write XC, okay? Do we have XL? No, but instead of XL, we have omega and L. Omega and L. XL is equal to what? Omega L. Omega 100 pi times 0.2. XL is equal to what? 20 pi ohm. 20 pi ohm. Replace into this equation, R was given, 100. Plus 20 pi square. Z is equal to what? 118 ohm. 118 ohm. This is the first part of the question. The second part, what is unknown? Guys, the phase difference between current and total potential difference. What is the type of the current? Doesn't matter. Why? Because the circuit is connecting series connection. In series connection, what do we mean by the current? Can we say this is total? Yes. Can we say this is IR? Yes. IC, IL. And phase difference between current and total potential difference. If you remember, this one VL and this one VC. And this is VE total, okay? If you remember what we have here, VR, IR, I total, IC, V total, and current, it means that this angle, theta is equal to what? Tan inverse. And can we use VL minus VC over VR? No, we have to use XL over R. XL over what? Over R. Okay, guys, because we have only XL and resistance in this circuit in this question, to find the phase difference between the total potential difference and the total current, we have to use this equation to find and determine this angle, okay, which is equal to XL over R. So we don't have XC because the circuit we don't have a capacitance. And the final answer for the theta is equal to what? Is equal to 32.13, and it is positive because we don't have XC. Question 2. If the source in item 1 is connected across a capacitor of capacitance, instead of inductance, if we have capacitor of capacitance with resistance, R, XC. We don't have XL, guys. We don't have XL in this circuit. XL is equal to what? 0. VL is equal to what? 0. Okay? What is unknown? The capacitance is given is equal to 2 microfarad. You have to convert to farad. How? Multiply 10 power negative 6 farad. Okay? Connected in a series connection with the resistor of resistance. Resistance is equal to 50 ohm. Calculate the impedance of the circuit. What is unknown? Impedance of the circuit, which is Z. And the phase difference between current and the total potential difference is the same thing. Okay? How can I determine Z? Z is equal to what? R square plus negative XC square. Why? Because we don't have XL. Remove XL. XL minus XC, which is 0 minus XC, XC. Okay? Negative square positive, but guys, we don't have XC. But instead, we have frequency. Okay? We have what? We have the frequency in this circuit. Sorry, we have omega. Omega. XC is equal to what? 1 over omega C. Omega 100 pi, C 2 times 10 power negative 6. XC is equal to what? XC is equal to 1592.3 ohm. Replace into this equation to what? To determine Z. R 50 square plus XC we didn't have, but we found 1592.3 square. The total impedance in this circuit is equal to what? Is equal to 1593.2. Okay? Phase the angle between potential difference and the current, tan inverse XL minus XC, but we don't have XL. What does remain? Negative XC. Don't forget this negative over R. Tan inverse negative 1592.3 divided by 50. Divide by what? Divide by 50, yeah, which is equal to negative 31.8. Tan inverse theta is equal to what? Theta is equal to negative 88.2 degree. So what does the negative sign indicate for the angle? Indicates that the circuit has capacitive or capacitance characteristics. Okay. Question 3, the source in item 1. Question 3 is also related with the question 1. Now connected across inductance, resistance, capacitance, series circuit. We have all in resistance, inductance, capacitance. Connect series connection to AC circuit. We have R, L, C, resistor, inductive impedance, capacitive impedance. And we have V across R, V across inductance, V across capacitance. Okay? IR equal IL equal IC, but potential difference is not equal. And this is source, VE total, IE total, and Z. Okay? Resistance, 20 ohm. Capacitance, 4 times 10 power negative 6 farad, 4 microfarad. Inductance, L, 2 times 10 power negative 3 Henry. Calculate phase difference between the circuit current and the total potential difference. What is unknown? The phase difference between the circuit and the current and the total potential difference. Okay? How can we determine the phase difference? The phase difference between what? Current and total potential difference. Tan inverse XL minus XC over what? R. Do we have XL? No, but we can find it. L. Omega in item 1 was given 2 times 10 power negative 3. XL is equal to what? 0.628 ohm. How about XC? 1 over omega C. 1 over 100 pi times C was given 4 times 10 power negative 6 is equal to 795.77 ohm. R was given 20 ohm. Guys, which one is bigger, XL or XC? Absolutely, the XC is bigger than XL. What does it mean? What do you mean by XL bigger than XC? Sorry, XC bigger than XL. If XC is bigger than XL, theta is what? Is negative. Let's check, guys. How can I determine the phase difference between between the total potential difference and the total current using this relation? Theta is equal to tan inverse. Do we have XL? We didn't have, but we found 0.628 minus, do we have XC? No, but we found. Divide by resistance, 20. Theta is equal to what? Is equal to negative 88.5 degrees. In this way, you can find the total, the phase difference between the total potential difference and the total current. Guys, look at question 39. Very easy question, and be careful. This type of question is bringing the will be bringing the Wasario exam. Be careful, okay? In the below circuit, as shown in this figure, in this circuit, calculate the total potential difference. Calculate what? Total potential difference across the source, A and B, across A and B. What do you mean by across A and B? It means the source, V total. How about potential difference across R, VR, L, VL, C, VC? VE total is equal to what, guys? Is equal to VR square, VL minus VC square. Replace. Do we have VR? Yes, was given. 3 volt. VL, 10 volt. VC, 6 volt. V total is equal to what? Is equal to 25 under square root 5 volt. This is the total potential difference. And also you can use this relation to find V total, IE total times Z. But we don't have Z, we don't have IE total, that is why we have to use this relation. Okay? Question 40. Calculate the impedance of the below circuit. What do you mean by impedance? Z. Capacitive impedance, XC. Inductive impedance, XL. Resistance, R. But impedance, Z. Z is equal to what, guys? R square XL minus XC square. Do we have R? You have to look at the circuit. Yeah, 6 ohm. XL, 24. XC, 16. By calculator, Z is equal to what? 10 ohm. This is the total impedance in this question. It's very easy, just plug in, okay? Guys, look at question 43. But before solving this question, we have note. Look at the note. If the question asks for potential difference across the coil, not pure inductance, we have to find potential difference across the coil. Guys, we have 2 different types of the coil. Pure coil, not pure coil. Okay? We have pure inductance and coil with resistance. Pure inductance, what do you mean by pure inductance? It means that resistance is 0. We have only XL. We have only what? XL. So V of the coil here is equal to what? Is equal to I times XL. When does V coil is equal to I times XL? When the coil is pure inductance. What do you mean by pure inductance? Negligible of what? Resistance. The resistance is ignored. Assume that this coil has no resistance, only has impedance. Sorry, inductive impedance, I mean. Coil with resistance. What do you mean by coil with resistance? It means that the coil is not pure. The coil is not pure, guys. If the coil is not pure, it means that we have both, like, what is this? This is coil. If the coil is not pure, how can you determine potential difference across this coil? V coil. In not pure inductance, can we say R is equal to 0? No, R is not equal to 0. R is equal to something. XL also equal to something. In not pure coil, if the coil is not pure, do we have resistance? Yes. Do we have inductive impedance? Yes. How can we determine the potential difference across this coil? V coil, guys, V coil is equal to what? You have to use the Pythagorean theorem. VR coil, VR of coil square plus VL square. Why we have to use Pythagorean theorem? Because resistance with inductance is perpendicular. What is the total potential difference between these two potential difference? V total, it means V coil. V total is equal to what? Which is V coil. VR square, VL square. So this equation came from the Pythagorean theorem. When does this equation can be used to determine potential difference across the coil? VR square plus VL square. If the coil is not pure, if the coil has resistance. And guys, look. How can I determine VR of coil? Ohm's law. I times R of what? Pure or coil? The resistance of the coil, not pure resistance. And how can I determine VL? I times what? XL. Okay? Look at question 43. An inductive coil of resistance. This is the resistance of coil. So can we say this coil is pure? No, this is not pure, guys. Not pure coil. The coil has resistance. The coil has what? Has resistance. Assume that this is resistance of the coil. Okay? We have both R and XL. R is given 10 ohm. This is the resistance of the coil. This is not pure resistance. Be careful, okay? And inductance L, 0.5 Henry. Okay? Connected series with the capacitor of capacitance, C. So we have to add a circuit here. Connected with what? Capacitance. Now we have what? Coil and capacitance. But the coil is not pure. It has resistance. So that is why we have to count for the resistance. Okay? Capacitance of capacitor is 150 times 10 power negative 6 farad. Okay? An AC source of effective voltage, source voltage, it means that VE total is equal to 250 volt. This is VE total. AC source of effective potential difference, it means VE total, okay? And frequency 50 Hertz. This is the given value for this question. Okay, guys, look. What is unknown? A, the effective value, VE, effective value of what? Alternating current. IE total. What is unknown? IE total. IE total. How can you determine IE total? IE total, guys, is equal to VE total over Z. Is equal to what? VE total over Z. But we don't have Z. How can you determine Z? R square plus XL minus XC square. Do we have XL and XC? No. XL is equal to what? 2 pi FL. 2 pi 50 0.5. XL is equal to what? XL is equal to 157 ohm. This is XL. How about XC? 1 over 2 pi FC. XC, 1 over 2 pi FC, 21.22. 21.22 ohm. Replace in this equation. Do we have R? Yes. 10. XL we didn't have, we found. Minus XC also we didn't have, we found. Don't forget this square, please. This is Pythagorean theorem. By calculator, Z is equal to what? Z, I got 136.24. What is this? This is the value of Z. Replace into this equation to find IE total. VE total, 250. Z, 136.24. IE total is equal to what? 1.84. Because the circuit was connected in series connection, can we say this I is also IE across R, IE across L, IE across C? Yes, of course. Because the circuit is connecting in series connection, so this total current is also the effective current across resistance, across inductance, and across capacitance. Now we have IE total, IEC, IER, IEL. Branch B, guys, look at branch B. In branch B, what is unknown? Look, branch B, the effective value of potential difference. What do you mean by effective value of potential difference? VE. But across what? VE across what? Across coil. VE coil and VE across capacitance VC. What is unknown? V coil. Guys, do we have the resistance of the coil? Yes. The coil is pure? No, it's not pure coil. It is not pure coil, okay? So it means that it has resistance. If the coil has resistance, which equation can be used to determine V coil? VR square, VL square. Do we have VR? No. Is equal to IR. I, we didn't have, but we found 1.84. R, 10. VR is equal to 18.4 volt. How about VL? Is equal to IXL. I, still 1.84, yes. XL, 157. Is equal to what, VL? 289. This is VL and this is VR. Replace into this equation. VR, we found 18. VL, we found 289 square. V across the coil is equal to what? 289.6. What is this 289.6? This is potential difference across the coil. So the potential difference across the coil, because the coil is not pure coil, so that is why we have to count for both resistance and inductance. Okay? And also we have to find potential difference across the capacitance. VEC. Across the capacitance, we have to use almost the IEC times XC. I, still 1.84 years. XC, we didn't have, but we found here 21.22. Which is equal to what? 39 volt. This is V across the capacitor. Okay? V across the capacitor. This question is very good question. Be careful, guys. Okay? Now we are going to solve another question. Okay? In section 3, chapter 6. Okay? So I got many requests from the students to upload all sections, especially section 3 in chapter 6. I will promise you that inshallah I will be uploading all chapters and all topics that included for the Wizari exam. Okay, inshallah I will uploading all the lessons of the chapter 6 is section 3, and after finishing the chapter 6, we will start, inshallah, chapter 7. Okay? Guys, question 24. That's all for today, inshallah. In the next lesson, I'm going to solve the other questions in RLC series connection to AC circuit. Have a good time and keep up your best doing.